Newton's law of motion. So firstly, we'll have to get to know who is Sir Isaac Newton. So Isaac Newton was an English mathematician, physicist, and astronomer born in 1643. He is renowned for formulating the laws of motion and universal gravitation, published in his seminal work Philosophia Naturalis Principia Mathematica in 1687. Newton's law revolutionized scientific thought, laying the foundation for classical mechanics. Additionally, he made significant contributions to optics, developing theories on light and color through his experiments with prisms. Newton's work remained fundamental in the field of physics and has had a profound influence on scientific advancement. So, firstly, what is motion? So, motion is the action or process of being moved or moving. Motion occurs when an object changes its position relative to a reference point. It's described by concepts like distance, speed, velocity, and acceleration. Objects in motion follow the laws of physics, such as Newton's law, which explain how forces affect motion. Essentially, motion involves in changes in an object's location or orientation over time. So there are three laws of motion. Firstly, inertia. Secondly, acceleration. And thirdly, interaction. So firstly, I'm going to tackle what is inertia. So inertia is an object at rest remains at rest, and an object in motion remain in motion and constant speed and in a straight lines unless acted on by an unbalanced force. So inertia is the inherent property of an object to resist changes in its state of motion. According to Newton's first law of motion, an object at rest will remain at rest, and an object in motion will continue moving at a constant velocity unless acted upon by an external force. Inertia explains why objects tend to maintain their current state of motion or rest and requires an external force to change that state. This fundamental concept of physics helps understand how objects behave and why they respond the way they do when forces are applied to them. I've given a example of inertia, a coin on the top of a glass. So the example involving a coin in a glass demonstrates the concept of inertia. When you place a coin on top of a glass and you swiftly flick the card out from underneath, the coin falls into the glass without being disturbed. So this phenomenon is due to coin's inertia, which is its resistance to changes in its state of motion. When the card is quickly removed, the coin tends to maintain its state of rest due to its inertia. Thus, it falls straight down into the glass. As per Newton's law of motion, which states that an object at rest will remain at rest unless acted by an external force. Secondly is acceleration. So Newton's second law states that the acceleration of an object depends upon two variables, the net force acting on the object and the mass of the object. The acceleration of the body is directly proportional to the net force acting on the body and inversely proportional to the mass of the body. So acceleration is a fundamental concept in physics that describes the rate at which an object changes its velocity over time. It can occur in two ways: a change in an object's speed, direction, or both. Acceleration happens when an object speeds up, slows down, or alters its direction of motion. It is calculated by dividing the change in velocity by the time taken for that change to occur. Acceleration occurs due to the application of forces, as described by Newton's second law of motion. This law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. Understanding acceleration is crucial in comprehending how objects move and react to forces in the physical world. And I've given an example of acceleration. So one boy represents he pushed the ball. Secondly is he pushes the car. So when passing the ball, the acceleration occurs as you apply force to the ball, changing its initial velocity to a higher or lower value. As you throw the ball, you're altering its speed and direction, causing it to accelerate. The ball's initial state is at rest or in motion with a certain velocity. When thrown, your actions imparts a force on the ball, causing it to accelerate in the direction of the force applied. This acceleration results in the ball gaining speed or changing its trajectory. Pushing a car involves a different type of acceleration. In this scenario, you are applying force to overcome the car's inertia, resistance to changes in motion. As you exert force by pushing the car, you're causing it to accelerate from a state of rest or from a slower speed to a higher one. The acceleration of the car depends on the magnitude of the force applied and the mass of the car, as described by Newton's second law of motion, where F is the force applied and m is the mass of the object and a is the resulting acceleration. So both examples demonstrate how applying force can result in the acceleration of the objects, either by changing their speed or altering their state of motion. And thirdly, what is interaction? So the interaction law of motion refers to Newton's third law, which states that for every action, there is an equal and opposite reaction. In essence, when one object exerts from a force on one another object, the second subject stimulates exerts a force of equal magnitude but in a positive, opposite direction on the first object. This law highlights the mutual interaction between two objects and explains how forces come in pairs. It is fundamental in understanding the relationship between interacting objects and how forces operate in physical systems. The interaction of forces between two objects is described by Newton's third law of motion, which states for every action there is an equal and opposite. And I've given an example. So, when one body exerts a force on the other body, the first body experiences a force which is equal to magnitude in the opposite direction of the force which is exerted. So the above statement means that every interaction there is a pair of forces acting on the interacting objects. The magnitude of the forces are equal and the direction of the force on the first object is opposite to the direction of the force on the second object. And that's all. Thank you.